Hey guys, this is Mrs. LaRue, your Academic Lab Algebra 2 teacher. Those of you who see me every other day already know that, but I just want those distance learners out there to know that they should be going to their Schoology course, and every day I plan on putting a little video of 1 or 2 problems from that day's lesson, so that at least at home, if you're stuck, you have something you can look at. I'm just starting that, so I don't have stuff from the beginning of the chapter, but next chapter, I should have every day just a new little 5 to 10 minute video clip. So if you're stuck on your homework, you have somewhere to go. For this, I'm going to be doing a practice test. You have a test coming up this week on either Wednesday, I think, or Tuesday, somewhere in there. And I want to go through some problems that are really similar to those on which you'll be tested. I go through them extra slow, so I might make 2 videos, we'll see. If it goes well, you're ready for the test. If not, I'd run through these again. So, you can run through them with me or just watch, but often, it's best to write. So I'm going to share my screen here, hop on my iPad, and we are going to go through some practice problems. So for this first problem, it is evaluating for a given value of x. What I was telling kids in class last week is that everywhere they see the variable or variables, replace it with parentheses. And some of the problems in their homework had x's and y's, and I said, well, let's do this for the x's and this for the y's. So if it had been 2xy, it would look like this right here. The reason it's helpful to do that is because it avoids the sign errors, and that we're going to go throw a -2 in every set of parentheses. So depending on if you're allowed to use a calculator or not, if you're allowed to use a calculator, I would go use one right now. You have it, but make sure you enter every set of parentheses. These 2 negatives right here do not make a positive. That's the most common mistake. With our rules of order, we need to, when we do our please excuse our dear Aunt Sally, the excuse or the exponent and the parentheses here take precedent. So a -2 times a -2 is 4. And then we had that negative out front. A negative times a negative is a positive. And then we have the -5, or the subtraction of 5. And then addition and subtraction gets done left to right. Again, if you're allowed to use a calculator, I would just enter that expression after you've shown your substitution. But we have a -4 plus 6, which is 2. And 2 minus 5 is -3. The next one, it says simplify and combine like terms. So first thing we need to do is get our terms untrapped from the set of parentheses by multiplying that negative in. A negative times a negative is a positive. So we have a positive 6y on the first jump in here. -2 times 5 is a -10. And then we have the plus 6y. The terms with the same variables to the same powers are like terms. So I have 6y's plus 6 more y's. I have 12 of them. I always say if you have 6 of them and 6 of them, you have 12 of them, because I don't want you making that a 12y squared. So 6 apples and 6 apples is 12 apples. So we have 12 y's minus 10. We have just simplified and combined like terms. So make sure those parentheses you distribute for those. Write an algebraic expression. What that means is there's a variable in it. You're going to be multiplying, subtracting, adding. That shows how much money you have left in your savings account. Okay, so you saved up $1,500 this summer. Okay, and now school has started. You've cut down on your hours, and you found you're only making 80 a week. But when you make 80 a week, if it said spend, you would subtract, but making's going to add 80. Now, if you leave it like this, which is really common, that's only 1 week. So we're making $80 a week, let's say for the rest of the school year, or maybe for the rest of the year or whatever, but we need to put in a W there for how many weeks. So if we were working 4 weeks, we'd get 4 80s. added to that 1,500. So here's our algebraic expression for the amount of money we will have saved. Save means add. Again, if it's spending, you subtract. For solving our equations, some kids like to put the line down through the equals. That's totally fine if you do that. It's not required. Remember when it says to solve, we're trying to figure out when we're all done with this what our variable equals. What our variable equals. So we really need to first and foremost get it untrapped from those parentheses. So let's go do that. I want to figure out what y is while it's stuck inside the parentheses here. So I'm going to get it unstuck. Make sure you bring this negative with a subtraction in because there's really a little 1 right there. So we're multiplying by a -1. On this first top here, 3 times 2 is 6. So I have 6 y's. 3 times -5, because remember that subtraction is really plus and negative if you like to do that, but it's a -15. The -2 is not what we're hopping in. You might say, well, you drew it. I'm actually attaching this to the negative sign. What's right directly in front of those parentheses is not a -2. It's that subtraction sign. So the -2 gets written down. And now I'll hop the -1 times y in for a -1y, or just -y. And then a negative times a negative is a positive. Next thing you do is you combine like terms on both sides. So I'll have 6y minus 15 on the left, and those don't combine, they're not like terms. But over here I've got this minus or -2, and I'm adding 1 to it. So if it's 2 below 0 and it goes up a degree, we're now 1 below 0. And I still have the minus y. Now remember, our goal is, what is y? Well, I can't go grab it yet because it's on both sides of the equation. So you have to move it. I like to move the smaller one because I like to avoid negative signs. So I have 6y plus 1y is 7y minus 15. And then this is gone, that's why I did it, is equal to -1. Now I can attack the y. So notice when you're solving, you have to first of all get it out of the parentheses. Secondly, combine like terms. Thirdly, get the variable on one side, and then you'll be back to the algebra you love, right? We add 15 to both sides to undo that subtraction. We get 7y equals. Again, if you have issues with your arithmetic, this would be something where you want to double check it on your calculator, enter it exactly as you see it. -1 plus 15 is 14. To undo multiplication, we divide, and we get y equals 2. I would like it if you would pause the video and go try to do number 5 on your own following those steps. You need to, on both sides of the equation, first of all, untrap x, then combine your like terms, then get the variable on one side, and then you'll be looking at one that you'll really like to solve. So pause the video. All right, now that you're back, let's on this side, hop that in. I can't do anything on the left. Those aren't like terms, so it's all nice and clean and ready to go. It's going to equal x. Then we have plus 3x. And remember, we multiply these, so be careful. I know visually it looks like 3 plus 1, but we're multiplying that, and it's 3 times that stuff. And then that plus 2 just hangs along on the back side. I have 2 like terms. I have the x plus the 3x, so I have 4 of those. And then I have 3 plus 2, so I just have 5. On the left-hand side, I still have that 5 plus 4x. Now, I need to get the variable on one side. Well, when I subtract the 4x from both sides, I end up having it disappear from both sides. So it's gone, right? What I get is a true statement, 5 equals 5. What that means is that it doesn't matter what x is. 5 equals 5 every day, every second of every minute of every hour of every week of every year. It's never going to change. It doesn't matter if x is a gazillion, 5 is 5. Right here at this spot, you'll notice these are the exact same equation. They're equal no matter what. So that's what, when you get 5 equals 5, that means the answer is all real numbers. I don't know how your teacher told you to write that. It's probably just all real numbers, or maybe all real numbers, or maybe the symbol for all real numbers. That's whoever you have for a teacher, write what they told you to write. But had we gotten something, had we solved and had something like 0 equals 7, well, that never happens. So that would be no solution. All right, the next one, we're going to solve this for the variable t. Right now it's solved, for p. Right now it's solved for t. It says t equals. Well, I don't want t. I want to know what p equals. Well, then you need to unwrap it and get rid of everything that's in the way by doing the opposite. So the first thing you should do is, since that's divided by q, you should multiply by q. That'll wipe it off, right? And since it's 5 times p, you should divide by p, right? So if you were to do a rewrite on this, you'd have q times t equals 5 times p. I always tell kids, circle what you're solving for and get rid of every layer in front of it by doing the opposite. This is 5 times p. It's not 5 plus or 5 minus. The opposite of multiplication is division. Then these cancel. So your answer would be p is equal to t times q divided by 5. So you always do the opposite. Let's try another one of those. Let's suppose that y equaled negative 6x over w. And I said solve it for x. All right, now watch. You're going to multiply by w. Sometimes kids will just grab and work on the left, and I say that's great. If you multiply by w, this will go. Then it's negative 6 times x, so don't add 6. It's not x minus 6. It's negative 6 times x. So we'll divide by negative 6, divide by negative 6, and all that's left is x. Easy peasy mac and cheesy. This one's a little harder. This one's a little trickier because I told you to go circle the variable you're solving for, but you'll notice it's in 2 spots. So we're going to do what we did on the solving, where we got the variable on one side. You might say, but there's a bunch of variables. I want the one I'm solving for all on one side of the equation. Remember, when we solve, we want our equals. Well, I can't have 2 of them, right? So what I'll do is I'll take and I'll subtract that UR from both sides. I'm really going minus U times R minus U times R. Okay, and what that'll do is move it. Okay, now I'm trying to go circle it because I want to get R all by itself, and it's in 2 spots. So what we're going to do is factor it out. Okay, it's like dividing an R. I call it the undistributive property. So when you used to say 2 times x plus y, and your middle school teacher said multiply that in, that's exactly what we're doing in reverse. I see a 2 in both of them, so I'm going to pull it out, and I'm staring at an x plus y. Okay, so in this one I see a r in both of them. I want to get it by itself, so I'm going to pull it out of both, and what I'm staring at is a t minus u. All right, now I can go attack that r. I'm going to circle it. And what do I need to do? I need to get rid of that t minus u. Well, I always tell kids, read it. If I were to ask you, what does this say? Or if I were up at the board and I said, read this, you'd say r times t minus u. Well, when you say times, it means you divide by what's in the way. So let's divide and cancel, cancel. The answer is r equals 3t over t minus u. And actually, t can't equal u, but that's for another day. All right. A rectangle has a length. Well, you better get a picture down, right? Has a length that's 5 times its width. I always ask kids, which one don't you know anything about, the length or the width? And the answer to that is the width, because I know the length is 5 times the width. If somebody told me the width, I could get the length. If the width was 2, length is 10, right? But they didn't tell me anything about the width, so that gets my variable. The length is 5 times the width. Well, on a rectangle, opposite sides are the same. So there I go, right? Perimeter means we walk around the perimeter of the yard. And that means we add up all the sides. So I would say the 5w plus the w as I walk along here, plus another 5W plus another W has to equal 50. These are all like terms up here. I have 5, 6, right? 6 W's and then 6 more W's. I have 12 W's that equal 50. Then I divide both sides by 12. And W would equal 50 twelfths. You could reduce it. You could go decimal, and then your label would be, there are no labels. Okay, so again, just walk around it. If it tells you that the width is, say, 7 times the length, then length, 7 times the length, length, 7 times the length, and you just add them up as you go around. 1 and 7 more makes 8. Then I have 8 more, so I have 16 lengths that equal whatever they tell me the perimeter is. I just did that one. Write an inequality. What's an inequality? It's a this, a that, a this, or a that. All right, less than, greater than, less than or equal to, greater than or equal to. So the sum, which means add, difference is subtract, product is multiply, and quotient is divide. This is the sum of 4 and a number. I don't know what it is at most 7. So if somebody said, well, how old's your son? I'd say, well, he's at most 7. Can he be 10? No. Okay, at most 7 means 7's the most. So we have to stay under it. If I'm at most 7, I could equal 7. Okay. So how much money do you have and how much does it cost? Well, I know it's at most $10. That means it's 10 or less, okay? The product, that means multiply. Again, quotient is divide, difference you'd subtract. 5 and a number is at least. Somebody said, LaRude, how old are you? I'd be like, oh, I'm at least 50. You know, that means I'm over 50, but maybe I am 50. You make that guess. That's the end of the first half of review, and I'll make another one too. So there'll be 2 videos for the first half of the chapter and one for the second half of the chapter. So I hope that was helpful, and I am going to find my stop share button. And again, if you would like, if you really want to get a good score on that first test, I'd run through these again so that you go in there and you're like, I'm going to crush this. Anyway, have a good one.